Hello everyone, welcome to Iegc Gate Coaching. Welcome to Iegc Gate Coaching. So today we'll be discussing about Gate Mechanical online coaching provided by Iegc, and subsequent there is one technical session for theory of machine by Mr. Anubhav sir. So first we will go through course details which provided by Iegc for Gate 2021 and 2022 mechanical engineering online coaching. So here the classes are held on both weekdays and weekends, and the weekdays classes are happening from Tuesday to Thursday, and the timing is given as 9:30 p.m. to 11:30 p.m. and weekends classes are on Saturday and Sunday. So Saturday timing is 2 p.m. to 7 p.m. and Sunday it is 9:30 a.m. to 2 p.m. The total course duration is 6 months for this July batch, and the total number of hours we are teaching is close to 450 around hours, 400 plus. So in this 400 plus hours, we will be teaching all technical subjects, engineering, mathematics. We will be also taking aptitude at the end, and we will be going like a few subjects parallel, which also I'll be explaining you guys, and we will be covering 100% syllabus around December end, 1 month prior to gate exam. Gate exam generally happens in February month, and apart from these classes, you guys will also get study material in e-form for all the subjects. You'll also get topic-wise assignments for self-practice in e-form, and after every topics there will be assignments for every subject, so that you guys have to practice. And for that also there will be some doubt session on Monday or Friday for assignment practice. And apart from these assignments, we also have weekly online exams. So online exams will be happening on our student portal, and it is exactly on gate pattern. Now, apart from this, as I mentioned, we have doubt and problem solving classes, and the fee for this complete course is 20,000, 25,000, and 1 year means it's a gate 2021, 2 year means it's a gate 2022. So for 2 years course, it is 37,000. How it first year you guys have to pay 25,000, and 12,000 is next year based on the what support you guys are taking. If you repeat all the classes, then you guys have to pay 12,000 for online classes, and if you have specific support, then fee will be according to that. Apart from that, you will also get the e-books for engineering, mathematics, aptitude, and all other technical subjects. So this is whole course details. So you guys have any concern or any doubt here? Want to ask something about course features or anything? And classes are live interactive classes, and classes will be happening on Iegc online platform, and recording of the class will be also available after class, so you guys can watch a class again online anytime. Yeah, Gautam, Rahul, Vijay, or anyone, any concern here? Okay, yeah, what will be student teachers ratio? Sure. See, we are teaching from last 2 years around 40 odd student, okay, and we are a team of around 10 people. So you can say for every 4 students, there is one teacher. And see, in gate mechanical, majorly there are 4 modules. So for every module, we have 2 teachers. And then there are supporting staffs also, those who support us in creating assignments, creating exams, and they also take care of the doubt support. So I will come to those points, okay? Nothing to worry. So this is about our team. So you can see this thermal sciences is like fluid and thermal sciences. That is section 3 in GATE mechanical syllabus. So we have 2 people, Mr. Rishi and Mr. Akshay. Yesterday Akshay has delivered one topper stock, and he is under 100 ranker, both in GATE and Iegc as well. Then for applied mechanical and applied mechanics and design, there are 2 teachers including me and Mr. Anubhav sir. and this is known as section 2 in GATE syllabus of GATE Mechanical. Then for section 4, we have two teachers, Mr. Naveen Kumar sir and Mr. Parampal sir. So Mr. Naveen sir will be starting, around July 12th, section 4. Okay, and Mr. Param sir will be also supporting for SAM. Then for mathematics also we have two teachers, Mr. Prashant sir and Mr. Karthik sir. So to you guys, Mr. Karthik sir will be teaching, but both Mr. Prashant sir and Karthik sir are available in a support group. Then for aptitude, we have Mr. Shivakant sir, and will be teaching at the end. And he's a BTech from IIT Roorkee. He was earlier Times faculty, and he teaches well. Now, once like about team, we will come to GATE Mechanical Engineering syllabus. So you guys can see the GATE Engineering Mechanics syllabus is, as I mentioned earlier, divided in 4 sections. So section 1 is what mathematics, but we include in that aptitude as well. So this engineering, mathematics, and general aptitude together is around 25 marks. So mathematics, the syllabus is more, but still there are some less marks than aptitude. Okay, and we also have to teach 50 plus hours or around 50 hours to complete this whole mathematics syllabus. Okay. So next part in GATE mechanical syllabus is applied mechanics and design. In applied mechanics and design, there are majorly 4 subjects. One is engineering mechanics, which we are going to start for you guys as early once class is commencing. And then we have mechanics of solid, then we have theory of machine, then we have machine design and vibration. So theory of machine and vibrations are more connected, and machine design and the solid mechanics more connected. So this complete, section is more of derivations and mathematics. And in this section, you guys can secure full marks, and the weightage for this section is 25 marks. Okay, so this section is very interesting and has a lot of involvement of physics and mathematics. Then the third section, which is fluid mechanics and thermal sciences. So in this section also you guys have multiple subjects like fluid mechanics, thermodynamics, and application, and heat and mass transfer. Now here they mention in syllabus heat and mass transfer before thermodynamics, but many of the concepts in heat and mass transfers require thermodynamics knowledge. So again the syllabus is this section has a weightage of around 25 marks, and this is very interesting for most of the candidate who write GATE mechanical exam, because here what day to day in practical life what we see is what thermodynamics and fluid mechanics in surrounding to us. So a lot of good practical example will be given by Rishi sir and Mr. Akshay when they take classes. So Rishi sir will be taking care of thermodynamics and HMT, and Akshay sir will be taking care of fluid mechanics part. Now the last part, section 4. So section 4 has also several subjects, and it's very much a subjective, theoretical part. So here the questions will be mostly repetitive, and again the weightage is 25 marks. So if you want to be real topper, you want to get top rank, then you cannot neglect this part, though it may not be that interesting. So you have to prepare this part thorough, and there are some hot topics in this section like machining tool, casting, forming, joining. So these two are hot, where more questions are asked than other part like industrial and production engineering part, and then inventories there, operation research, CNC. So all these things are there in this, and engineering materials, metrology as well. So uh, from our side, this complete section will be taught very well, and we request whoever really want to get best rank, they should do good practice for this section as well. Now, how we will be covering syllabus over the duration of 6 months? So here I have mentioned we will be starting with these subjects like mathematics, thermodynamics, section 4. Then we move to engineering mechanics and solid mechanics part. Then we will be moving to fluid mechanics and machine design part. And in November, we will be teaching HMT and theory of machine. And in the last is like application part of both fluid and thermo. And plus there will be aptitude classes. So this is how the syllabus is planned. I will do some modification here, and I will share with you guys. Okay. Now about Iegc work, so we have given link for sample study material, sample assignments, sample online exams, sample videos. So have you guys gone through those? Anyone? Kind of material we give, the kind of assignments we provide, kind of exams we have online. Anyone? Okay. Yes or no, you guys can say. Okay, if you guys have not gone through, I request you guys to go through it, because before joining, we want to make sure you guys are thorough with work, what kind of work we are doing. Okay. And here the focus is not on quantity, it will be on quality, and we will be also not bothering to take hundreds of students. We will be teaching limited number of students properly. That's what we do, okay, from last 3 years in Bangalore. Now so I will open one by one these as well, and show you guys how these looks like. Okay. Then this is our online doubt support. Currently it is through WhatsApp group. We may move to new online platform. So you can see here mathematics aptitude. This is the mechanics part. This is the module 4 part. And then you guys can see it's a thermal sciences part. And this is the post gate guidance. Once like you have some rank, so what you guys have to do, so how to use that rank, so everything we support. Okay. Now these are the few toppers from IGC. So we have got people in PSU, we have got people in railway, we have got people in IIT, we have got people in NIT in last 2 years. Then these are our contact details. So we are Bangalore based institute, and this is our phone number. These are our mail IDs. This is our website, and we are also present on social medias. You can track us on Facebook or YouTube. YouTube this year we are making good. From last 2 months we are making good presence. Earlier we were not active on YouTube channel. And our classes, offline classes in Bangalore, happening in Marathali area in Bangalore, and we have only one offline classroom program anywhere in India as of now. And our office is situated also in Bangalore, and the address is provided here. So this is brief discussion about IGC online this coaching support for GATE mechanical engineering. And now I will make you guys go through few of the IGC work. So you guys can see this is the iitiansgateclasses website, and here you will find all the details about us, what different programs we are providing, and what all related things. You can see the link and everything is provided. Now, if you go to Gate study materials, you can find the sample assignments here for gate mechanical, and we can open any assignments. So you can see this is how assignments will be looking like. We have taken the problem from different sources, and we ask students to first practice, and then we support for all these. So this is about our assignment part. So for every subject we have shared the sample assignments. You guys can go through website and can find. Now I'll share the sample study material part as well. So here you can find the sample study materials. If you take any subjects, you can see the uh, fluid mechanics. So currently our study material is a handwritten, but there is a plan to convert in type 1 soon. So this is how for every subject you will be getting study material. Already we have done for engineering mechanics, solid mechanics, mathematics, conversion from this handwritten to typed one. Or if you take this module 4 study material, so you can see this is for casting. So it's more of theoretical part. So it is visible, right? Gautam, it is visible, right? Or Harini or Lakshay? Yeah. So this is about material part. So I have shown, assignments, and I have shown you guys this as well, study material. Then we can see the few more assignments. So I have opened for HMT, then I will open for machine design. So you can see this is how the assignments are prepared. We solve all different kind of problems here, and so this is another assignment for machining and machining tool, which I was telling it's very important in gate mechanical. In section 4, it has higher weightage. So you guys can see we have taken, the problem from ISRO production engineering paper, IES preliminary. Okay. So this is about, these assignments and study material support. The last and which is very important is what online, this exam. So we have weekly online exam, and I will show you guys for mechanical branch. So this is our online tool where exams happens, and whoever join our classes, we share this credential for this online exam. And you can see here the different subjects are listed. So I'll just open exam, for thermodynamics. If you take, so you will see multiple exam. Okay, these are the topic wise exam for each and every topic which we teach. So let's say you can attempt thermodynamics first law exam. So if I attempt first law exam, then you will see this is how exam looks like. So your gate exam will also looks like similar, and you guys will see the questions are coming in this pattern, and there are two kind of questions in gate. One is a MCQ and one is a numerical answer type. So you'll see this is numerical answer type questions. So here you cannot use keyboard. You have to only use mouse and type. And in exam, scientific calculator is not allowed. So there will be virtual calculator like this. So we have a good virtual calculator which is also very quick. You guys can use, and it works very quickly. Okay, so this is how. Now you can answer any questions, and you can see we have negative marking. uh, Yeah, guys. So you can see the question, you can read the question, and here time is flying. Okay, and it's a MCQ question of 1 mark, so you can see the negative marking as well. Okay, so and you can see what all questions you have answered. I have answered zero. What has not been answered, not visited, reviews. All these options are there, like gate exam. So suppose I am answering this. If I move to next question, it will say you have answered one. So once I answer, then there are 20 questions. So we set a time of 60 minutes. So every question is almost given 3 minutes time, and once I attend all the questions sincerely, then I can submit exam. So once you submit exam, result will be generated, and you can see here this is how result looks like. So whatever question I have attempted, it is wrong, so I can see I got negative mark. How much time I have spent, when I attended, what is my percentage, what is my percentile, failed or pass. So you can see I got rank 1 because this exam was not attended by anyone till now, as we have not started thermodynamics yet. Okay, so you can see all this, and it will also show how much time you have spent on particular question, and which all questions you have visited. Below that, all these details, you will be seeing answer sheet. In answer sheet you will see correct options. Okay, but for our exams we do not share the solution. You guys have to explore, or you guys have to ask doubts in our open discussion forum. So if I do any question correctly, it will show by green. Since I have done it wrong, so red, and which all I have not attempted, it is white. So this is all about our student portal, and we have around 70 plus exam. So those exams are divided in three parts. These topic wise exam, then subject wise, in fact four module wise, and full syllabus exam. So this is about Iegc online this test series portal. And apart from that, timetable. So we share the weekly timetable on our website, and here you guys can see this timetable, and you guys can see the timetable for each week. Suppose this is the June 30th to July 5th. So if you click here, you will see the classes, okay, for each branch, and we have multiple branches of engineering. So this is for gate mechanical and aerospace. So currently we are teaching solid mechanics, fluid mechanics, mathematics. So time is properly given for from what time to what time we will be taking. So each and every details will be shared, and it is shared on website. It is in public, anyone can find. So this is how best we maintain our transparency. So any concern or any doubt? Now come to our online, classes. So this is our Iegc online class platform, and currently one mathematics class is going on. So I will get connect you guys through to that class. So you guys can see the screen. So this is our class. Okay, I will because class will get disturbed. So almost everything I have shared, and this is all from my side. So now I will hand over, to our Anubhav sir for technical discussion. So Anubhav sir, you are there. I can see. I am handing our presenter to you.
Hello, all. I hope you can hear me. Please give me a yes if you can hear me. You can type yes on the chat box if you can hear me. Gautam has written yes. Okay, that's great. Just give me a sec. I'll share my screen sometime. So how many participants are here? I want a yes from Gautam. I got a yes from Gautam, Alam, Lutz. Just give me a second before I join. Class. Okay, today's demo class. We'll start today's demo class. And let's see what exactly we are going to start with. We are going to start with theory of machines. Okay, we are going to have a demo, 1.5 hours of demo of theory of machines. Let us see exactly what exactly is theory of machines. First, let us see the relevance, the importance of theory of machines with respect to gate. We call it TOM. Everybody must be knowing it. We call theory of machine as TOM. Okay, so let us see what is the relevance of TOM with respect to gate. Okay, so if you see the mechanical engineering paper, the theory of machine is right on the top after 3 subjects. Means it comes on the 4th number, right? The first is the aptitude. You know, always aptitude consists of 15 marks out of 100 marks. Thereafter, if you see maths has an average of somewhere around 12.8 marks. Okay, so I'm giving you the average. Okay, so production has an average of 12.5 marks. And if you see theory of machines, it is just after that. It is just after production. In fact, it is ahead of subjects like strength of materials, fluid mechanics, and thermal engineering, right? Thermal in the sense, not the complete thermal engineering. It is ahead of thermodynamics. Okay, so definitely this is a very important subject. So it needs to be prepared very nicely, right? Okay. So what are the plus points of preparing TOM theory machines properly? First of all, as I said, it has an average of around 10 marks in GATE. Okay, this subject is very interesting. This subject is very interesting. As we go through the lecture, you get to know a lot many interesting points comes up, right? It is also very scoring. There's a very scoring marks. If you have good understanding of theory of machines, you don't need to revise the subject too much. If you have the concepts, definitely you can score marks, right? You can score good marks here in this subject. Okay, and otherwise there are 2 other positive sides of the subject. It is a lifelong companion. Means if you study theory of machines we get to see throughout, everywhere, in all aspects of our life, right? So whenever you're walking down the road, whenever you're doing anything, most of the things we use are machines. We are surrounded by machines, right? So if you have a good knowledge of the subject, if you've read through the subject, if you have basic understanding of the subject, you will always come to know the working principles of all the machines surrounding you, right? And that gives a very immense amount of satisfaction, and you really feel like an engineer. So that is one of the plus points of having this subject. And as I said, this is a very practical subject, right? Whatever you will study, you can actually apply it on your practical side. Most of the machines we have seen in our life, right? So whatever you're studying here, we can actually practically feel how it is happening, right? So also, I'll also say that this subject requires a little bit of imagination, and it is a pure engineering subject, right? So it is a pure engineering subject. You have to use imagination, you have to use all the basic skills, right? And definitely, if you have good knowledge in theory of machines, and it helps you to score good marks in GATE. Okay, so I hope you got the importance of the subject with respect to GATE. Okay, so let us see how is the distribution of the chapters in this subject. Okay, So let us take an example. Okay, let us take an example. So I hope you guys are hearing me, and you can see an image, right? You can see an image. Can you tell me what exactly is this? Let me check how profound you are in mechanical engineering. Can you give me what is this? You can type in the chat box. What exactly is this? Piston, petrol engine. What about others? Come on. See, this class is going to be interactive. Okay. Me, four-stroke petrol engine. Okay. Me going on speaking and speaking. And if I don't have any interaction from your side, this class is going to be meaningless. You'll feel sleepy, right? So you have to be engaged. You have to be engaged. I'll be asking you a lot many questions and you have to keep on replying me. Okay. So your mind has to be active. Okay. Okay, this is a schematic diagram of a four-stroke petrol engine, internal combustion engine, right? This is a schematic diagram of a four-stroke IC engine, you can say. Okay, since there is a spark plug, you can say that this is a petrol engine, right? So I'll not go into detail of what exactly IC engine is, right? We are not going to discuss all different things that are written here, but I'll try to go through the chapters. Okay, I'll go through the chapters. So the first, to make the IC engine, okay, IC engine, somebody told piston. This is not just the piston. This is only this portion is piston. This is the piston, right? So this is a rod, connecting rod. Okay, this is the crank. So what happens exactly here? What happens here is in combustion chamber, due to combustion taking place in the combustion chamber, the pistons moves up and down. Okay, we are not going much into detail. How does this happen, right? Later on, while studying flywheel, I'll give you a brief idea in theory machines. So the piston goes up and down because of combustion taking place, right? So when the piston goes up and down, what happens? This rod, this connecting rod also moves along the piston. It has to move, right? So if the connecting rod moves, this crank, this is known as crank. This crank also has to move, right? These are all rigid bodies. These are all rigid bodies. If the connecting rod is moving, it has to move. And with the piston making up and down motion, the motion of the crank is actually rotation. Crank rotates. Okay, the crank rotates. And now we actually connect this crank. Okay, there's a crank rod here. Okay, there's a rod. We connect this to the tires. We connect this to the tires. So the crank rotates. So along with the crank, the tire will rotate. Okay, there are different mechanisms here. I'm not directly connected to the tires. There are mechanisms here through which we actually connect it to the tire. Okay, so basically, why I'm taking this example is because this is nothing else. This is an example of a machine. Okay, this is an example of a machine which is used in the automobiles, right? Which is used in cars, trucks, right? Not in a truck because it is petrol. What before starting, if you want to manufacture this machine, right? This is the IC engine, right? This is the IC engine. If you want to manufacture, first you have to understand how this top up and down movement of the piston can create rotation of the crank, isn't it? This understanding is very much important. If you don't understand how the top and up and down motion of the piston is creating the rotation of the crank, actually you'll never be able to design it, right? The designing part will come first. Only after that you will manufacture it, right? First is to design it, and to design it you have to understand it, right? So that's why you have to understand how this does this work. brings revolution, right? Just very study for that is simple mechanism. We call it simple mechanism or planar mechanism. We call it simple mechanism or planar mechanism. So that is where we are going to start the subject from. The first chapter will be simple mechanisms. Okay, why it is called simple, right? Why it is called planar, we'll study in detail when you get into this chapter, right? So this is the mechanism. This is the mechanism part. How movement of one of the link. This piston is a link. Okay, this piston is a link, or you can say element, or you can say member. How movement of the piston, how to and fro, up and down movement of the piston can cause rotation of the crank. This is what we have to study first. That is what we are going to study in simple mechanisms. Okay, let us now proceed. Only studying of the mechanism is not going to do. You'll also have to calculate the velocity and acceleration. If the velocity of the piston is v, what is the velocity of the crank? We must be able to know it, right? What will be the velocity, or you can say angular velocity of the crank? We must be able to predict it. If you cannot predict, then how will you manufacture the car? Right? How will you design the engine? So definitely, if you know the velocity of the piston, you must be able to predict the velocity of the crank. Only then you'll be able to decide the RPM, the speed of the engine, right? So here comes the velocity and acceleration analysis. After studying mechanisms, we will go on to proceed on to the next chapter, where we will study how to create a relationship between the velocities and acceleration of different links of the mechanisms. Right? So once we do that, after that we can actually go for manufacturing. After that we can go for manufacturing of the machine. Okay, we'll get to know the detail when we are studying the chapters. Okay, again, if you see, there is a very big importance of gears in a IC engine, you can see, right? Whenever you want to transfer the power, right? Whenever you want to transfer the power from the crank, let me say from the crankshaft to the wheel, definitely the wheel will not be directly aligned here, right? The wheel will not be directly aligned here, right? Wheel will be somewhere else. So you have to transfer the power from this shaft somewhere else. The wheel might be somewhere here. The wheel might be somewhere here, right? So the shaft, the wheel is actually attached to this shaft. The shaft of the wheel is somewhere else. The shaft of the wheel is somewhere else, and this is the crankshaft. Right? So the IC engine is giving you the power here, right? The IC engine is giving you the power here, and this has to be transferred to some other shaft. Only then the wheel will rotate, isn't it? Only then the wheel will rotate. So to transfer these powers, we'll have to use gears and gear trains. To transfer these powers, we'll have to use gears and gear trains. I hope you are understanding. I hope you are understanding. Please give me a yes. All of you, please give me a yes if you're able to understand what I am talking about. Okay, Lux, Gautam, that's good. Prithvi, okay. What about others? Great. So I want the session to be interactive. Okay, I know some people might be using phones and they might be not be able to type, right? But that is okay. Yeah? That is okay. If you're having any difficulty, that is okay. But my class will always be interactive. We'll keep on talking to each other. Okay, because see, in physical class it is very difficult. It is very easy. I can see your face and I can get to know who is able to understand and who is not. But here, online class, it is very difficult, right? Because I cannot see your faces, and it is your responsibility to whenever you're feeling, whenever you have any doubt, whenever you are feeling that no, I'm not being able to grasp the topic, the concept. Okay, you have to intimate your teacher, right? So that has to be from your side. Okay, everything has pros and cons. Okay, if I'm not being able to, there are have physical classes in classroom class, online classes have many other different fantastic pros. For example, I'm being able to use the schematic diagrams. See, beautiful diagrams, I'm being able to use it, right? It enhances your understanding capability. It enhances your understanding capability. That is the wonderful benefit. Okay. The con is I'm unable to see your faces. If you are physically present, definitely I can understand your doubts properly. I can solve your doubts properly. But that is not going to be a barrier. Don't worry. We'll keep on interacting and we will keep on talking to each other, right? And I'll make sure that all of your doubts are clear, and we will not move forward unless and until your doubts are clear. Okay, we'll not move forward unless and until your doubts are clear. And we are also going, if somebody has some of the students are weak, will stay behind. Okay, others can leave who have their time, who have understood the concepts. They can leave at the end of the class. They can stay behind, and we'll spend some extra time understanding the concepts. Okay, but that is not going to be a problem. Okay. Okay. Thereafter, we will go through, this is the order in which order we are going to see the subject. Okay. Thereafter, we will see kinematic and dynamic analysis of slider crank mechanism. This is also known as slider crank mechanism. This whole mechanism we are talking about, this is known as slider crank mechanism. This is a slider, the piston is the slider, and this is the crank. This is the crank. Okay, this is a slide. This is also known as slider crank mechanism. So you will see, we will do analysis. Detail analysis, whatever we have learned here in the first 2 chapters, okay, we'll apply it to this mechanism and we will try to find out the kinematics and dynamics of this slider crank mechanism. Okay, so I hope you know what is the difference between kinematics and dynamics. Do you know what is the difference between kinematics and dynamics? Give me yes or no. Yes means you know, no means you don't know. Do you know what is the difference between kinematics and dynamics? You're thinking, is it so? No, Pratibh is saying no. Somebody is saying yes. Okay, but still okay. I have one no, so I'll just give you a very fast description what is kinematics and dynamics. See, kinematics. See, if you remember your class 11, okay, class 11, right? If you remember your class 11, just after class passing 10, you're entering 11. When you start your physics, the first chapter is units and dimensions. The second chapter is vectors. The third chapter is motion in a straight line. The third chapter is motion in a straight line. That portion we call it kinematics. Whenever you're starting motion in a straight line, we call it kinematics. What do we use there? V is equal to U plus AT. These are very familiar formulas like S is equal to UT plus half of AT square, right? V square is equal to U square plus 2AS, right? We use these formulas, right? So this portion, whenever you're studying this portion, it is known as kinematics, okay? So here in kinematics, we try to find out the velocities, like what is the initial velocity, what is the final velocity, what is the time taken to cover up certain distance, what is the distance covered, how long will that go, right? What should be the acceleration or deceleration? We talk about all those things, but we never comment on what is causing the change in velocity. We're studying the motion, but we never study the cause of motion. What is the cause of motion? The cause of motion is force. In kinematics, we don't study the cause of motion. We study the change in motion, how the motion is happening, how much distance is this covering in a certain amount of time, what is the initial velocity, what is the final velocity, but we don't study what exactly is causing the motion, right? That part we actually study in dynamics. From kinematics, we take out the acceleration. From kinematics, we'll find out the acceleration, and in dynamics starts from Newton's first law of motion, right? And in dynamics, we use Newton's laws of motion, and we say if acceleration is A, the force behind this acceleration is equal to F into M. The force behind this acceleration is equal to F is equal to M into E. So you take out the acceleration from here and you put it here, and we actually find out what is the force. This is the part, this is what dynamics is. Okay. So we'll do the same thing here. while studying this chapter, kinematics and dynamics of slider crank mechanism, we'll do the same thing here. What we will do, we'll first try to find out the relationship between velocities and acceleration. If the velocity of piston is v, what will be the velocity of the crank, right? And after that, we will find out if the force in dynamics part, we will find out if force F is acting on the piston. Then what will be the force or torque on the crank? Force or torque on the crank. So this is a very systematic subject. You see, this is going to be very interesting, and this is a very systematic subject, right? Exactly, we'll do what the way you have followed it. Okay. Then we'll study flywheel. What are flywheels? Flywheels are used to store energy. Okay. We'll go into detail when we're studying this subject topic. Okay. Then we'll require balancing, because this system generally is not balanced. The system is generally not balanced. Okay. And if the balancing is not proper, it causes vibration. If the balancing is not proper, it causes vibration, and vibration is very, very detrimental to any machine. Vibration is very, very detrimental to any machine. It will cause the failure of the machine very early. The machine will fail very early than the designed life. Okay, so we'll study balancing, and then we'll study vibration. Even though we balance the machine, we'll not be able to completely balance it. Some amount of vibration will always be there. Right? So we'll talk about vibration, how to reduce the vibration further, right? Thereafter, we'll study about gyroscope. These are generally not used in automobiles. These are used in aeroplanes and ships. We'll study why gyroscopes are required and how does it help. Okay, and at last we'll talk about cams. Okay, cams and followers. I'll give you an example. This is the inlet valve, right? This is the outlet valve. You can see in the IC engine, right? I'll use a different color here. Okay, this is the inlet valve. You can see inlet valve. This is the outlet valve. The opening and closing of inlet and outlet valves are actually controlled by cam. Nowadays, electronic things have come up, but still, it is still prevalent. The opening and controlling of the valves, inlet valves, and the exhaust valve are actually done by cams. So we'll have a brief discussion on cams. Okay. And this subject will be to the point with respect to gate. This course is for preparation of gate. So you'll be focusing more on the things, on these topics on which have appeared in previous year gate papers and which are probable to come up in the future gates. Okay, we will not go divert. This is not a academic class where we will learn all different aspects. No. See, in gate, your time management is very important. You don't have to study things which are not required in gate, right? So that is a very important point. So this subject is going to be exactly tailored according to the gate exam. I hope this is clear. Is all the subjects that we are going to take care of in this subject clear? Give me a yes if you have understood the chapters. Come on. Are the people falling asleep? What about others? Lux said. Okay. I hope you understood. Okay. And okay, let us proceed on to the chapters. I'll give you a brief introduction of myself. My name is Anubhav Parasa, right? And I have, now this has become 4. I have 4 years of teaching experience of mechanical engineering. Okay, so I'll be taking your lectures for two subjects, that is theory of machines and engineering mechanics. Okay, before starting this subject, okay, this demo lecture, I'll tell you actually engineering mechanics precedes this subject. Okay, you need to have concepts of engineering mechanics clear, okay, which you don't have it right now. Okay, but this is just a demo lecture. I don't want to take the basics. I'm taking something from the middle of the subject so that you can understand how exactly things are being taught. Okay, I don't want to start from the first chapter because first chapter everybody does it very beautifully, right? So I'm starting something from the middle, which you can also understand. Okay, so that you can actually get to know the way, the methodology of our teaching, right? How we actually teach. Okay, so let us make class interactive. I will keep on asking you questions. I'll ask you to confirm that you have understood the topic. So we are starting all of. Are you ready to start gears? Okay. Okay. Beautiful. Yes. Yes, Alan. Now you replied. That's good. Cool. Okay. No problem. As you go through the subjects, the chapters will get clear of the chapters. Okay. Let us start with gears. So, what is the function of a gear? क्या करता है ये gear? What does gear do? There are primarily three roles of a gear. There are primarily three roles of a gear. The first is to transmit power. First is to transmit power from one shaft to another. Recently, I've seen, right? The crankshaft could be at a different location, and the wheel, let me say, it is at a different location. The wheel is at a different location, right? So you need to transfer the power from crankshaft to the wheel shaft. You can say the axle. So to transfer that power, you actually requires gears. To transfer this power, what we require is gear. Okay, it will definitely not be one gear. I'm just giving you an understanding. Okay, this is not going to be like this. Okay, this is not going to be like this. We're definitely we'll see how it look like. Okay, so but I hope that you got it. If you want to transfer the power from one shaft to another shaft, we have to use gear. Are there any other method? Are there any other method of transferring power from one shaft to another? If we use a gear, can you give me any idea? Bells. Gautam is saying bells. Okay, good, Gautam. Anything else? Coupling. Okay. Chain and links. Chain links. Okay. Anything else? Okay. Bells. Chain drive. Okay. Rope. And one more is rope drive. Okay. One more is rope drive. We can use bells. You can use chain. You can use ropes. Okay. Coupling. I will tell you one thing. Coupling is little bit different. Okay. Coupling is also used to transfer power from one shaft to another, but those shafts are generally in line. Means they're either those shafts. If you want to use a coupling, those shafts has to be in line or at least intersecting. If in line, then we can actually use coupling like there are lot many couplings, right? We can use or they should be at least inclined to each other. We can use hook joint or universal joint. Okay, to transfer power between two shafts which are at an angle. Okay. If you talk about parallel shafts, we can use Oldham coupling. Okay. But the problem with coupling is we cannot change the velocity ratio. Means if one shaft is revolving, rotating with the omega, the other shaft, if you transfer the power, the other shaft will also rotate with the same angular velocity omega. We cannot change this. Okay. However, if we use gears, belts, and chains and ropes, we can actually alter the speed according to our requirement. Okay. So we can increase the angular speed or decrease the angular speed. So this is the basic difference between coupling and disc drives. Okay, power drives. Okay. But what is the problem with belt, chain, and belt drive, chain drive, and rope drive? The problem with belt drive, chain drive, and rope drive is slip. Okay, there's a slip in these three drives. Okay, so because of slip, we cannot have a exact output. Okay, I'll give you an example. Okay, you are riding a bike. Okay, you always want that at a particular position of the accelerator, you want the bike to move at a constant speed, right? But if there is a slip, what will happen? Sometimes at a particular position of the accelerator, sometimes the bike will move faster, sometimes it will move slower. There will be a fluctuation of speed. And that fluctuation of speed is definitely something which you don't want. Right? That fluctuation of speed is definitely something you don't want. Okay, that is one problem. Okay, this is to quite an extent reduced by using chain drive. But the problem with chain drive is it is difficult to use chain drive everywhere because of the area it requires. Okay, because of the area it requires, and there is a small amount of velocity mismatch even in chain drive. We'll talk about it later on. So I hope you got it. You can transfer power using gears. You can transfer power using belts or chains or ropes. But gears is preferred over the other three because of slip. Okay, in gears we'll have no slip. We'll continue, and we will get to learn even more about slip. How are gears preventing slip? We'll see to that. Okay, so let me now move on to the second aspect, that is the function of a gear, that is to magnify torque. Okay, that to do magnify torque. How many of you have ever drive a vehicle, be it a four-wheeler or two-wheeler? Yes or no? Come on. Okay, Lux is saying I have. Alam is also saying no. Gautam haven't. I have. Yeah, I have. Okay. Okay, Gautam. No problem. But you must have heard whenever you have driven any vehicle, right? Where it starts from? When you are starting it, we always start it from gear number 1, isn't it? Or you start it from gear 4 or 5? One or tell me. We start the vehicle when it is at rest. We start it from 1, right? First gear. Yes, exactly. We start it from first gear. Why we start it from first gear? That is because when the vehicle is stationary, it is hardest to move the vehicle. It is very tough, right? So gear number 1, it magnifies the torque. How it does it, we will see later on. Okay, when we will get into the subject, okay, we'll get to know. I will not be able to explain it right now, okay, because there are many concepts. But if you put it in gear 1, the gear helps to magnify the torque. And once the momentum is created, once the vehicle start moving, right, we generally shift onto higher gears, because once the momentum is created, there is less requirement of torque. Okay, I hope you got the point. This magnification of torque is also actually done by gear. Okay, we put onto gear number 1, 1, 2, 3, 4, 5. These are actually gears of different sizes. which are installed in the gearbox. If you put onto gear number 1, what happens? Gear number 1 gets engaged, and gear number 1 is a smaller gear and it provides more amount of torque. We'll see it later on. Okay. And the third aspect is to increase or decrease in speed. Third aspect is to increase or decrease in speed. All of us know, I'll take the same example while riding a 4-wheeler or a 2-wheeler. If you are on the first gear, no matter how much you press the accelerator, the vehicle will not move very fast, right? So if you want to increase the speed, you'll have to change onto higher gears, right? Slowly from gear 1 to gear 2, 2 to 3, 3 to 4, right? Only on the top gears, the car moves in a fast manner, right? Or the vehicle moves in a fast manner. You will change the gear to lower gear, again it will reduce the speed, okay? So to increase or decrease the speed again, we have to use gears. Okay, how is this done? We'll see. How is this done? We will see later on. Okay, but I'll give you a general formula. Try to remember this. We'll see this again, but I'll try to give you a general formula. Power is equal to torque, this way, torque into angular velocity. Okay, you can, power is equal to torque into angular velocity. Okay, power is equal to torque into angular velocity. Let us see. Always use dimensions. Always try to see all the formulas using dimensions. What is the dimension of torque? Dimension of torque is Newton meter. Force multiplied by distance. And what is the dimension of angular velocity? Radian per second. Radian is a secondary unit, so I'm just writing it 1 by second, right? Newton meter is also unit of energy. We can call Newton meter as joule, so this unit becomes joule per second. And what is joule per second? Joule per second is nothing else but unit of power, that is watt. Joule per second means energy per second. The rate of consumption of energy is nothing else but unit of power, that is watt. Okay. See, this is a general idea. Whenever you come up with a formula, try to decompose this formula in this way and try to see. This is very, very important to gain confidence, right? In exam, many of the questions you will be able to solve using this technique. So whenever you are learning any formula, always try to do this. Might be right now you are unable to understand everything properly, how I have done it, right? But you have to keep on practicing this again and again. Whenever you're coming up with some formula, try to decompose it. This is torque. What is torque? Torque is force into perpendicular distance. What is the unit of force? Force का unit है Newton, right? What is the unit of distance? Meter. What is the unit of omega? That is angular velocity, radian per second. Radian is a secondary unit. You don't use it here. So I'm just writing it 1 by second. Newton meter. Force into displacement. What is force into displacement? This is work done. Work done का unit क्या है? What is unit of work done? Work done's unit is joule. So this becomes joule per second. What is joule per second? Joule per second is watt. Right? This is one way to remember. I gave you this idea. I hope you will practice this and we will do this, all different formulas will come through. Okay. You see, power is always constant. Now you see power is always constant. Okay. Now you see the power is always constant. Means if you accelerate different example. Let us say we have a motor, electric motor. We have connected it to this plug. Okay, when we have switched on the plug, the motor will start running. Right, the motor will start running. Okay, now the energy supplied by electricity is constant. The energy supplied by electricity is constant. That is, power is constant. You have to understand is the power is constant, and power is equal to torque into omega. Power is equal to torque into omega. Now these two quantities can actually change. This torque and omega, they can change. I'm giving you an overview. We'll learn this in much detail. As you go into it, go into the subject, we're going to learn it in much detail. Okay, just stay with me. All of you just stay with me. Okay, so torque into omega, this thing can actually change. How? I'll tell you. I'll tell you how. You use a small gear and use a bigger gear. Okay, the small gear is rotating at some speed, let me say omega 1, and the bigger gear is rotating at some other speed, let me say omega 2. Okay, the small gear is rotating at some speed, let me say omega 1, the bigger gear is rotating at speed omega. Okay, so I am connecting the electric motor here to the small gear. I am connecting the electric motor to here to this small motor. Now, the electricity is constant, means the power is constant. Okay, so what is the power I am giving? What is the power I am giving to this torque in the first gear multiplied by the omega of the first gear? Please give me a yes if you have understood what I am speaking. Who is giving? Given Gautam and Prithvi. This time, this. Okay. Okay. Okay, that's cool. So power is transferred from the small gear to this larger gear. This is what we are doing here. Can I say the power in the larger gear is the torque in the larger gear multiplied by the angular speed, sorry, omega 2, torque in the larger gear multiplied by the angular speed in the larger gear, isn't right? But we know that power is constant. But we know that the power is constant. The power is coming from the electric motor. The power is coming from the electric motor, right? Power is constant. The electric motor transfers the power to the small gear, and the small gear transfers the power to the larger gear. The power is actually, assuming no losses, no frictional losses, assuming there are no frictional losses, the power is actually constant, right? So I can say the power is equal to torque 1 omega 1. This is equal to torque omega 2. Is this occasion, is this equation okay? Give me a yes or no. Lux is saying, Gautam is saying yes. Okay, beautiful, beautiful. If you're unable to understand, even if there is an iota of the doubt, no problem. We will practice each and everything so many times, the things will get clear. Okay, the things will get clear. Okay, don't worry, don't worry. Anyways, so now I'm just trying to give you how the increase and decrease in speed takes place. Okay, when we'll study the subject in detail. Okay, you'll get to see. I'm just giving you a little bit of basics. I'm just trying to see. I'm trying to sense the students how good their basics are. Don't worry. Even if you have any doubt, iota of doubt, it will get clear. Okay. Now you see these two terms are equal. Now, if you increase the omega, because this is constant. You have to understand there is nothing else but this is constant. This term is constant, right? Similarly, increase the omega, that is the angular velocity, the torque has to come down, because the multiplication of both torque and omega is constant, right? Similar is the case here. If you increase or you can say if you decrease the omega, the torque will actually come up. I'm just giving you an overview. Don't worry if you are unable to understand it properly. Okay, this is what I'm saying. How these two are related. How increase and decrease in speed and torque are related. As the speed increases, torque decreases, and as the speed decreases, torque increases. That's why when you're putting the gear when putting the vehicle on first gear, the speed is less, but the torque is more. And as you go on to higher gears, the speed increases, but at the cost of torque. We cannot climb the uphill. We cannot take the vehicle uphill at a larger gear, right? We have to move on to the smaller gear. Only then it will be able to climb a uphill road, right? So because you have to increase the torque, and if you increase the torque, the speed automatically decreases. Okay, don't worry. I'm just giving you an overview, because having an overview, it always is better than to start the subject with complete blank mind what we are going to do, right? So I hope you understood what is the function of a gear. There are three functions: transmit power from one shaft to another. Okay, magnify torque. We require to magnify the torque many a times, right? Like we have to, like in the case of starting a vehicle from the rest condition, and increase and decrease in speed as per our requirement. There are lot many examples I can give, but let us limit to this. Slowly throughout the class we will get to know. Okay. So where these, let us go a little bit back. Let us go how were these gears invented. Okay, so the gears invention were as earlier as 4th century BC. 4th century BC means 400 BC. This is near to the birth year of Mahavir Jain or Gautam Buddha. This is near to the birth century of Mahavir Jain, Gautam Buddha. These gears were discovered so long back. There are evidences of using gears. Okay, but what before that? How were people transmitting power before that, or not transmitting power at all? No, actually, people were using, before 400 BC, people were using friction wheel. Right here, you can see an example of friction wheel. What exactly is a friction wheel? So you can see there are two different wheels. I'm giving you a diagram, small diagram. This is a wheel. So what they will do, they will make the surface very rough. Friction, they will increase the friction. Friction is increased by making the surface very rough. Okay, and they will bring two of similar wheels into contact. They will bring two of similar wheels into contact. And the rotation of one wheel will actually produce the rotation of other wheel. Right? So this is how they achieve transmission of powers from one shaft to another in earlier days, before the invention of the gear. Now, the problem with the friction wheel was it could do only low power transmission. And it could only low speed. The speed, they were unable to increase the speed. They were unable to increase the power, transmission of power. What was the reason? What could be the reason? The reason being at high speed and high power, this friction wheels experiences slip. Slip happens. And my dear, please believe me, we don't like slip. Right? If I am giving a input, I want an exact output. Machines are to be designed in such a way. And driving a vehicle, I should know if I put it in gear 2 and if I press the accelerator to this much amount, what will be the speed of the vehicle? If the output is not constant, sometimes it is moving at a high speed, sometimes it is moving at a slow speed. No, I'll get frustrated. I'll not buy that vehicle, right? So it is very important that if I'm giving some output omega 1, I want an exact output omega 2. I am not compromising my output. But in this friction wheel, the problem was slips were happening at a higher speeds. So for a particular input, omega 1, I'm not getting a constant output omega. This is not going to work, right? So such kind of devices which experiences sleep are known as negative drive. Okay, the negative drives, they have slip. Example of negative drive are gears, sorry, not gears, belts, rope, and even chain. Chain drive is also called, it is known as a negative drive because of the hexagonal effect. If you have seen the sprocket chain, the sprocket of the chain, it is something like this. So it experiences some amount of movement. It experiences some amount of movement. Okay, and with time, because of creep, the chain actually loosens up. With time, because of creep, the chains actually loosens up. You might have seen this with your cycle, right? If you have ever ride a cycle, after a prolonged use of the cycle, the chain actually gets elongated and you are not able to, you have to tighten up your wheel and do a little bit of adjustment so that the chain again gets back to a tight position, right? So that is the reason why these three drives are known as negative drive, that is because of slip. Okay, so let us see what happens, what is the mechanism at low power. Okay, at low speed, low power, it will be able to transmit power, right? So let us see what exactly happens. Okay, we'll have to use little bit of mechanics here. Okay, otherwise I'll come back to this later on. Okay, our class is till 5 o'clock. I want to give you some other views. We'll come to this to later on. Okay, because before theory of machines, anyways, you are going to go through engineering mechanics. Okay, so I'm taking your engineering mechanics classes, and it is going to be hell full of concepts. Okay, I will give you concepts throughout the chapter, all different concepts that you'll be using it throughout your engineering, not just in engineering mechanics. You'll be using those concepts in strength of materials. You'll be using those concepts in theory of machines. You'll be using those concepts in machine designs and whatnot. Okay, so that is the foundation of mechanical engineering. So let us go through engineering mechanics first, then we will actually try to see the mechanics. Okay, so to avoid this slip, the people came up with an idea. Why not bring in projections? Why not bring in projections on the surface? Initially, what they were doing, they were making the surface rough. Initially, what they were doing, they were actually initially in friction wheel, they are making the surface rough, right? So that because of friction, they are able to transmit power. Now, at higher speed, as it failed, they thought, why shouldn't we make some projections on the surface? So if there is projection on the surface, my dear, then definitely Unless and until this projection breaks away, there is no possibility of slip. There is no possibility of slip. Right? Unless and until the tooth breaks away, right? There is no possibility of slip happening. So for a constant input, you will get a constant output. And this is exactly what we want. This is exactly what we. I hope things are getting clear. So gears, my dear, these are gears. These are gears. These gears, my dear, are called positive drives. Why positive drive? Because slip is not possible. I hope you are understanding how the evolution of gear has been, right? So this is how two gears match with each other. This is how two gears match with each other. We'll go through different mechanisms. Okay, I'll open the complete gear in front of you. Not today, it won't be possible. That will be in the third, after 4 to 5 hours of class. Okay, I'll in fact open the complete gear in front of you. I'll show you what exactly is gear, how does it transfer power, and each and everything. Okay, but that will take some time. First, we have to get some basics. This is how you can see. This is how two gears match with each other, right? So one gear rotates, it causes rotation to the other gear. One gear rotates, it causes rotation to other gears. This projections you can see, these are known as teeth. These projections you can see, these are known as teeth. Okay, I hope you got it. Please give me a yes. Beautiful, beautiful. So now see the speed of the class. Initially it will be slow. I'll have to first understand all different people, and somebody might be feeling the speed is more, somebody might be feeling the speed is less. So I am keeping the speed of the class slow initially. Okay, so that all the students get into level. This is how I'll be teaching. Some students might feel okay, sir is teaching a little bit slowly, and this is how I do it, because I want some students concept might not be that very strong. Okay, so by teaching slow, I just want them to come up. Okay, bring their level up, and once the whole class gets into a particular level, then we slowly increase the speed of the class. Okay, that's how it is going to be in my class. Okay, so that's okay if the speed is slow. Towards the end, you will see that the speed will match up. Okay. Okay. Now let us see the classification of gears. Let us see the classification of gears. Okay. So you can do different classification of gears. In this classification, I am classifying gears according to the relative position of their shaft axis. Okay, according to the relative position of their shaft axis. Okay, the first is the parallel shafts. Okay, the shafts can be aligned in three ways. How? The shafts can be parallel to each other, right? The shafts can be inclined to each other. Right? Parallel shafts. These shafts are non-parallel, non-intersecting. Sorry, non-parallel intersecting. These are parallel, non-intersecting. And there can be a third classification. This is one shaft, and the other shaft this is the other shaft. This can be the three different configurations, right? Right? So what is this kind of shaft? This is neither parallel nor intersecting. Parallel भी नहीं है, so these are neither parallel nor intersecting shafts. So we'll have to transfer power. we will require to transfer power, whatever the kind of shafts might be. This is one condition, this is the second condition, and this is the third condition. Right? So let us see different types of gears we'll be using while transferring power between different types of shafts. Okay. So here I come with the first kind of shaft, that is the parallel shafts. What if the shafts are parallel to each other? Okay. Parallel shafts. So if the shafts are parallel to each other, the first kind of gears we will use is spur gear. Okay. Now, if the shafts are parallel to each other, the power can be transmitted between two cylindrical surfaces. Right? So, for example, you have one cylinder, you have another cylinder, let them touch each other, right? You just cut a part, okay? We can rolling. If the shafts are parallel to each other, the rolling motion can be actually transmitted using two cylinders, isn't it? If one rotates, simply like the friction wheel, very simple like the friction wheel, right? So what we do, we will actually take a part of this wheel. Okay, we'll take a part of this wheel. I hope all of you looking at me will take a part of the cylinder. We'll take a part of the cylinder and we will start making projections on the cylinder. Right? So for parallel shafts, my dear, the gears can be constructed using cylindrical surfaces. For parallel shafts, the gears can be constructed using cylindrical surfaces. Now, please listen to me very carefully. Please listen to me very, very carefully. Okay, you're entering a very, very important section. We're entering a very, very important section. Try to get the concepts clear at the first time here itself. Okay, this will be very, very beneficial for you. Okay, so parallel shafts, the first kind of gear we will be using are spar gears. Okay, so what are spar gears? Spar gears, are used when the shafts are parallel to each other, and in the spar gears, the teeth, you must be knowing now what teeth are, right? The teeth are parallel to the axis of rotation. Right? This is the axis of rotation. This is the axis of rotation, right? If you see the teeth are parallel to the axis of rotation. Right? You're getting the point? You can see physically, you can see physically, I have given you a diagram here. These are the teeth, right? These are the teeth. If you see, there's a parallel to the axis of rotation. This is the first kind of gears that appeared. This is the first kind of gears that appeared, but unfortunately, most of the gears failed. Why? That is because this gears has the problem of instantaneous. Please listen to me carefully. Instantaneous engagement and disengagement. What do I mean by instantaneous engagement and disengagement? See the teeth, right? You see the teeth here, right? When the teeth come into contact, strike at once. They strike at once. I'll just give you a little bit of overview. Let me say this is a teeth. I'm trying to draw a teeth. Okay, I'm trying to draw a teeth. Let me say this is a teeth, and there is another teeth which is coming from the top. There's another teeth which is coming from the top. Okay, so when the teeth from the top, it comes and strikes, the kind of engagement is a line engagement. The kind of engagement is a line engagement. Means the whole of the teeth will strike. The whole of the top teeth will actually strike the bottom teeth. And at an instant you'll get the engagement. And it will make a noise like this. Right? It just within a second, the whole of tooth came into contact. In just within fraction of seconds, the whole of tooth came into contact. So what kind of forces it will produce? It will produce impact force. It is an impact when at a very small period of time, the whole teeth is coming into contact and it is transferring the power. It will cause an impact. And because of this impact, my dear, what happens is the teeth fail, right? So impact, if you study strength of materials, you'll get to know, okay, you study strength of materials and you'll get to know that impact cause the stresses in case of impact are much higher than the normal stresses, right? For example, if I punch somebody in his face, it is very more likely that his face will get deformed, right? That is why we punch or slap, because if you punching or slapping, the whole force is transferred from my hand to someone's face at an instant, isn't it? And an impact happens. It also produces a sound, right? A very small amount of time, a lot of energy being transferred. And exactly this happens with the spur gear. All the teeth, they come into contact at once. The whole length of the teeth, or it will come into contact at once. The whole breadth of the teeth, it will come into contact at once. You can see it here. You can see it here. When the teeth will come into contact, okay, you can see it here, this red line, this teeth, and I'll take up a pink line, this teeth. The whole width of the teeth, they will come into contact at once. And this will cause a impact. And because of this impact, my dear, 99% of these spur gears fail. 99% of the spur gears failed at higher speed. That doesn't mean that we don't use spur gears. Use spur gears even now because they are easy to manufacture. The manufacturing of spur gears are the easiest, but if we use it for low speeds and low power transmission. Okay, we use it for low speed or low power transmission. I hope you got it. This is the first kind of gear, okay, that we use here. That is the spur gear. Okay. Now, what to do? The gears are failing. We are unable to use this spur gear for higher speeds. We are humans, right? We humans never stop whenever we have any problem. We solve the problem and move ahead. We have the corona time right now, and you see humans will eventually solve this problem and they will move ahead. Similarly, we moved out of spur gears and we invented something called helical gears. We invented something called helical gears, and this helical gear solved the problem of instantaneous engagement and disengagement. It solved the problem of impact stresses. How? We incline the teeth at a certain angle to the axis of rotation. My dear, for helical gears also, the shafts are parallel. If you see the shafts, they are parallel also for helical gears. But what we have done is, we have made the teeth incline to the axis of rotation. And this is a major improvement. It has actually taken away the impact stresses. What is happening right now? See, please see here. What is happening right now? Now, if there is any contact, suppose two teeth are coming into contact. This is a teeth and this is another teeth, let me say. Whenever they're coming into contact, the type of contact is a point contact. The type of contact is actually a point contact. They are coming into contact at a point, right? And slowly, this point will change, it will increase. The contact will slowly increase. It is a little bit difficult to show here. You might be able to feel it here somehow. You might be able to feel it in the diagram somehow. First, the 2 points will come into contact, and as the gear moves forward, look at this diagram. First 2 points will come into contact. As the gear moves forward, right, the full gear will be in contact, full tooth will be in contact, and thereafter, again it will reduce to a point contact, and it will actually get disengaged. So what is happening here? What is happening here is the power is transmitted gradually. Unlike spar gears. In spar gears, what is happening? Both the teeth are completely engaging at once. It is making a sound, and both the teeth are engaging at once and then getting disengaged, transferring the power and getting disengaged. So all the power is transferred in a very small amount of time. That is actually creating the impact stresses. Now in helical gears, the first only 2 points will come into contact. Then slowly, as the gear rotates, the full length of the teeth will be in contact. It is transferring the power slowly. It is transferring the power gradually. Then again, some part of the teeth will start disengaging, and again it will be reduced to a point contact, and thereafter the contact will go away. This is the beauty of helical gears. And my dear, the helical gears completely solve the problem of impact stresses. And it could be used in higher speed of rotation now. No problem. Without any problem, we are using helical gears at higher speed of rotation. Is this point clear? Give me yes or no.
Hello, sir.
Yeah.
Yeah. So, can we wind up in next 5 minutes, sir?
Sure. We'll wind it
Yeah.
up.
Yeah.
No problem.
Sure, sir. Thank you.
Okay, that's good. Gautam is saying yes. Alam is saying yes. Prithvi is saying yes. Lux is saying yes. That's good. Okay. These things are definitely easier to understand in physical classes. I can show you with my hand movement, but I'm trying my best to explain it to you. If possible, I'll get some videos. I'm trying to get some videos, animated videos. I'll show you animated videos and all. So that will make the class even more lively. Okay.
Yeah. Yes, sir. We can, play some videos. We'll plan
Yeah,
few videos
definitely.
first. Yeah, sure.
Right. Exactly. So, but this helical gears, a new kind of problem arises. What is that problem? My dear, the case of axial thrust. Now, just imagine how will these helical gears be actually transmitting power? How are these helical gears transmitting power? I'll just give you an example. Okay. So this helical gear, I'm taking one gear. I'm taking just the upper gear. So the force on the teeth will be something like this. Let me see. Definitely, the force will be perpendicular to the teeth, isn't it? Right or wrong? Give me yes or no. The force will be perpendicular to the teeth. If I want to transmit some force, it has to be perpendicular to the teeth, right? Okay. Now this force can be actually resolved into two components. So see here, this is one component and this is the other component, right? If this angle is theta, this is f cos theta and this is f sin theta. Okay. Now, my dear, this f sin theta is okay. This f sin theta is okay. It is helping in transmitting the power. But this f cos theta, it is a useless force. Now tell me, if you want to do, very simple, why I'm telling this as a useless force. In fact, it is creating a problem. You'll get to understand it. Suppose you want to rotate this. Okay, this is a, let me say, a gear or a wheel, whatever. I'm giving you two different forces. One is this force F1 and the other force is along the axis F2. If you want to rotate it, which will help it? F1 will help or F2 will help? If you want to rotate the wheel, F1 is a tangent, okay, and F1 is a tangent. Right, F1, right? F1 is this one. If you see, this is F1. This is F1, this way. This is F1. And what is F2? It is along the axis. So which will help in rotating the gear, F1 or F2? F1, right? Exactly. Very good. Very good. F1 will actually rotate the gear. F2 will never able to rotate the gear because this is axial, right? So this is okay. F sin theta is okay. That's why F sin theta is okay. This F cos theta is first useless. Secondly, it is causing a problem. What is the problem? Now to balance this force, you have to use bearings. Definitely. This shafts, where this shafts will go into? This shafts will be holded by bearings. You will have the bearing at the end of the shafts. Okay. So these bearings will have to balance this useless F cos theta. Will balance this useless F cos theta. The bearing has to balance. So there is extra load on the bearing. So what will happen? Eventually the bearing will fail. Eventually the bearing will fail. So this is not just useless force, the axial force, it is actually detrimental. It is harmful to the machine because it will exert a unnecessary force on the bearing. The bearing has to balance this force and eventually the bearing will fail. So was this force not there in spar gear? Let us see. If you see in spar gear, the force will be perpendicular to the teeth, right? The force will be perpendicular to the teeth. You see, you cannot resolve the force. There is no axial force. There is no axial force. Right? I hope you are getting it. The teeth, the force is perpendicular to the teeth. That's why there is only the radial force. There is no axial force. So we solved the problem of impact. The instantaneous engagement and disengagement, we solved it using helical gears. But we came up with another problem, that is axial force. And as I said, human beings will keep on finding solutions to all the problems. And what they did, they invented double helical gear. They invented double helical gear. What did they do is, they added, this is one single gear, okay, this is single gear, one side right hand helix and the other side teeth are inclined in the other way. So what has happened now? One axial force, this is producing. One axial force, this is producing. Both the axial force are on the same gear. What will happen? They will cancel each other. They will cancel each other, and what will be the total axial force? The total axial force is equal to 0. So this is the use of double helical gear. This is the use of double helical. I hope you are getting it. I hope you are getting it. Now, manufacturing of is a little bit difficult this way. Okay. Hence, we are using a cutter. We will have to use tool cutter, right? So while changing the orientation, the tool requires changing the orientation, the tools require some space to move around. To give a little gap. For example, a tool is coming this way, from this way it is coming here. Such now it requires some amount of space to its orientation. So to change the orientation, see, you can see the tool coming up here, tool came up till here, right? So it is cutting. Thereafter, the orientation to this direction, to the other direction. So it requires some space. So we actually provide with a tool runout. This space is known as tool runout. This is known as runout. So if the tool runout is there, it is known as double helical gear. And if tool runout is not there, then it is known as herringbone gear. If the tool runout is not there, it is known as herringbone gear. I hope you got to understand. Okay. So this is a herringbone gear, example of herringbone gear. You can see there is no tool runout. Okay. And this is actually a double helical. I hope it is understood. Please give me yes if you have understood. Okay, beautiful, 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 very good, nice. So we had a lot of class. We'll not proceed forward, okay? But I'll just give you a brief idea, very fast, okay? Thereafter, we'll come up with intersecting shafts, okay? Intersecting shafts. This type of gears are known as bevel gears, okay? You can see the shafts will intersect each other, okay? So bevel gears, again, there are straight bevel gears or spiral bevel gears, okay? Thereafter, you have Gerald bevel gear and Mitre gears. We'll get to learn about all these things. Okay. Then we have skew shafts. That is shafts which are neither parallel nor intersecting. Okay. Those type of gears are known as spiral gears or cross helical gears. This is, you can see, this is one of the shaft. This is one of the shaft. Right. They are not intersecting and not parallel. Right. We'll get to see. We'll learn about these things. Okay. Then you will get to see what is hypoid gear. Right? We'll see this is also non-intersecting. This will be one of the shaft, and the other shaft is going like this. Right? They are non-intersecting, non-parallel shafts. Right? Then you will have worm and worm wheel. Okay? This is again a very interesting thing. Worm and worm wheel. Okay? We'll see rack and pinion. Right? These are the different types of gears. We'll see. And where are these? Why are this important? Why we are studying the classification? We are studying this classification because the 1 mark questions. We have seen not many 1 mark questions today. What are the different questions we have seen? Let us see. Let us see what are the different questions seen. Okay, positive drives. I am giving you 4 examples. For option A, gear, belt, chain, rope. Right? Again, if the shafts are parallel and non-intersecting, if the shafts are parallel and non-intersecting, which of these you will use? Spur gear, helical gear, both A and B. Option C is hypoid gear, let me say, or bevel gear. Right? This type of questions are asked. Okay, if the shafts are parallel, what are the kind of the rolling motion can be transmitted between cylinders, cones, right? Hyperboloid surface. We'll get to learn all these things. Okay. The problem with spar gears are, right? I can give 4 examples, right? The problem of axial stress, or can say problem of axial force exists in option 1, spar gear, option 2, helical gears, option 3, double helical gears, option 4, herringbone gear. The axial force exists in which of the 4 gears? It is only in helical gear. We know double herringbone gear and double helical gear and spur gear does not have the problem of axial force, right? So this is why all these important things are important. These small things, theoretical things are important. You're not into numerical, right? Numerical is also hell interesting in gears, but for that you have to undergo 6 to 8 hours of class. Okay, so it is not possible in such a short period of time to make you understand all different things. But I hope you got to know how exactly the classes will be done here, right? We'll understand all different things related to all different things, right? I hope that you liked it, like the class, and I'm hoping to meet you all in classes very soon. Thank you, class. Thank you. If you have any doubt, any question, you can definitely ask me. I give you the time. I give you the time to ask any question, any doubt you have. Right? If you are clear with whatever we have learned today, it was short interaction, but I hope it was a good interaction. Okay. So give me a yes if everything is okay, or if you have any doubt, you can actually ask. You can unmute your speaker and you can ask your question, no problem. Thank you all of you. Thank you so much.
Thank you, sir. So hopefully these guys will meet you soon in engineering mechanics class, and it's already planned around 12th of July, once like classes commencing. So thank you guys for joining this session, and hopefully we guys all meet in regular classes, which is going to commence soon. So thank you all. I would have given time for some discussion, but due to time constraint, we will wind up here. Thank you guys. Thank you.